The views expressed in this presentation do not necessarily reflect those of NSERC or other institutions involved in this project. So for today's webinar, I've divided it into answering 3 key questions. First, I'll talk about what are exoskeletons and the different types of exoskeletons that are commercially available. Next, I'll talk a little bit about why construction companies might want to adopt exoskeletons and the factors that should be considered when adopting. And lastly, I'll share some findings from a recently published field study that we've conducted, trying to answer what are construction workers' perspectives on using exoskeletons for their work, and how did it impact their work, discomfort, and fatigue. All right, so let's jump into it. So what are exoskeletons? Exoskeletons are defined as wearable devices that augment, enables, and/or assist physical capacity. And throughout this presentation, you might hear me refer to exoskeletons as EXO. So over the past decade, there has been an emergence of exoskeleton manufacturers, and there are several exoskeletons that are readily available for adoption in the workplace now. In fact, we recently conducted an environmental scan for exoskeletons designed for work, and we found over 60 that were commercially available. I know it can be a bit overwhelming with the diverse variety of products out there, so let's talk a little bit about the different types of exoskeletons and how they are categorized. One of the things that exos can be classified by is whether or not they need a power source. Those that need a power source are considered active exos, and those that don't are passive exos. Active exos consist of external actuators, such as electric motors and pneumatic muscles, to augment the user's power and provide extra energy. Whereas passive exoskeletons, they do not need any actuators. Instead, they rely on mechanisms like springs and dampers to store and release energy. That's an passive exo. Exos can also be categorized by the movement or body part that they support. There are exoskeletons that are designed to support the hands, arms, legs, back, and there are whole body exos that support multiple body parts as well. And although we'll be focusing on industrial exoskeletons that are designed to be used in the workplace, there are also exoskeletons used in military and for medical and rehabilitation purposes as well. Now, as an example, I brought with me the exoskeleton that we've tested out in the field. So this is the Hilti XO01 that was developed in collaboration with Autobach. It's a passive industrial arm support exoskeleton, and so it's supposed to support overhead work. So the way you put it on is similar to a hiking backpack. And there's a waist belt that clips on around your hips and a chest strap that goes around across your chest. Now, the arm support comes from these cuffs that wrap around your upper arms, and it acts like an armrest that kind of moves along with your arm movements. Like so. And so once you have it on, there are ways to adjust it, but typically you would adjust it beforehand. So you can adjust the level of support that you get from the EXO using knobs back here. Now, the level of arm support should be no more than the weight of your arm, so you don't have to fight to bring it back down. And it's one thing I also wanted to note is that these exoskeletons are not meant to help you lift more or turn a 2-person job into a 1-person job. It's really meant to reduce reduce fatigue and the demands of overhead work. Okay, so we've established that there are several types of exoskeletons for various applications, but why might an organization want to implement exoskeletons? What might they want to consider if they're thinking about it? To understand this, we need to first look at the context of construction work. We know that there is a labor shortage in the skilled trades, and Canada's construction sector faces record high job vacancy rates. In fact, a recent report from BuildForce Canada indicates that over 90,000 construction workers in Ontario will retire over the next decade. That's over 20% of Ontario's current construction workforce. And the industry will need at least 116,000 new workers over the next 10 years to replace the retiring workers in order to keep pace with the expected demand growth. We also know that injuries and work disability are problematic for maintaining a workforce and preventing unwanted early retirement. This is a challenge. Compared to the general working population, those working in construction are 50% higher at risk of sustaining an injury. And of these injuries, musculoskeletal disorders make up more than 40% of workplace injuries and lost time claims within the sector. Now, the high rates of MSDs aren't surprising when we consider the context of work. Typically, construction work exposes workers to numerous MSD risk factors, including awkward postures, forceful exertions, vibration, repetitive movement, overhead work, and more. Given the labor shortage and the high injury risks in construction, there is a need to, one, attract a younger and more diverse workforce, prolong the healthy working life of the existing and aging workforce, and three, reduce musculoskeletal risks in the workplace. So reducing MSD-related hazards will play an important role in maintaining the workforce. And typically, it's recommended that hazards are addressed following the hierarchy of controls. As many of you may already know, this model ranks hazard controls from the most effective to the least effective level of protection. When choosing a control method, you should start from the topmost feasible level before moving on to the next. So starting with elimination, substitution, engineering controls, administrative controls, and personal protective equipment, or PPE. And so going through this model, many controls would have been identified at each level to protect the worker from the hazard. For example, the hazard of overhead work. Workers who work with arms above 90 degrees for even 5% of the day are over 2 times more likely to develop a shoulder injuries than those that don't. In terms of controls, for elimination, you can design work processes that avoid overhead work, like prefabricating components at the ground level and then lifting them into place using cranes or other lifting equipment. For substitution, you can use tools and equipment that reduce the need for workers to reach overhead, using things like extendable tools that allow the workers to perform tasks from a lower and more comfortable position. Engineering controls could include implementing mechanical aids like ladders or scissor lifts to position the worker at the correct height and minimizing the need for overhead work. Administrative controls may include rotating tasks amongst workers to limit the duration of overhead work. And despite all other efforts, there are times when overhead work still must occur. And in those cases, we can rely on things like PPE. So these PPE are things like shoulder harnesses and even arm support exoskeletons to help reduce fatigue and reduce the risk of injury. Although PPE are considered the least effective control in the hierarchy, exoskeletons could still offer several benefits given the dynamic and non-cyclical nature of construction work. Many studies have suggested that exoskeletons could potentially be effective in settings where engineering controls cannot be easily implemented. So there are a bunch of lab studies that have demonstrated exoskeletons to be potentially beneficial in the field. They have been shown to decrease the amount of muscle activity needed to complete various simulated tasks, like drilling, lifting, wiring, and welding. They have also been shown to increase endurance and reduce fatigue, and thus lowering the risk of MSD. Improvements in work performance and productivity have also been found, and this is measured by things like number of errors or the time it takes to complete a task. So if there are benefits, why don't we see these everywhere? Well, other than reducing muscle fatigue, the benefits in work quality and productivity have not been consistent in the scientific literature. Researchers have noted that the benefits of exos are very task-specific. And so it's important to note that many of these studies took place in a controlled setting, often with a group of university students performing a simulated task that they may be unfamiliar with, and for a shorter period of time, not an entire workday. And this may not translate to the real world. There's actually very few studies that investigated exoskeleton use by real workers when completing their tasks in real work environments. Stakeholders in the construction industry have also shared their perceived barriers to adoption. There was a great study by Kim et al. Out of the United States that interviewed construction industry representatives about their perspectives on adopting exoskeletons. And although they acknowledged the potential benefits, many expressed concerns about the ruggedness, effectiveness, versatility, and usability of exoskeletons on the job sites. They also questioned exoskeletons' compatibility with personal protective equipment such as harnesses. They also questioned whether the utilization of exoskeletons could be perceived as a sign of weakness, as in those who were using exoskeletons weren't capable of doing the job on their own. The stakeholders also shared some factors that would facilitate exo adoption. They indicated that having a chance to trial the exos and having training on it would be helpful. And of course, a key driver to adoption is knowing that there's going to be a return on investment. So there's still a lot of knowledge gaps in understanding what are the impacts of exoskeletons in the field with workers under real working conditions. For the rest of the webinar, I'll be talking about the study that we conducted aimed at providing a better understanding on this. Specifically, our study aimed to explore construction workers' perceptions of using a passive shoulder exoskeleton, identify tasks that it may be helpful and unhelpful for, and provide recommendations and considerations for further development of passive shoulder exos for its use in construction sites. For our study, we used a crossover study design, and our participant recruitment efforts targeted trades that commonly performed prolonged and/or repetitive overhead tasks. These included trades like electrical, plumbing, framing, drywalling, mudding, and taping. For the first 2 days, we divided our sample into 2 groups. So we had half of the participants perform their typical tasks as usual without the exoskeleton, and the other half perform their usual tasks while wearing the exoskeleton. After the 2 days, they switched conditions. So those who were working without an exo were now asked to wear an exoskeleton and vice versa. And we met with each participant 3 times a day at the beginning, middle, and end of their work shift to conduct a test battery of measurements. The test battery consisted of a set of measurements that allowed us to explore the effects of exoskeletons on various domains of the worker. We collected self-reported discomfort and fatigue through validated questionnaires, and we measured muscle strength and muscle activity through a maximum voluntary contraction with EMG or electromyography. We also recorded videos of common tasks that were performed, and we had a continuous measurement of the upper arm motion through accelerometry of the entire work shift. On the last day of the exo condition, we also asked participants straight up what they thought about the exoskeleton. So overall, we tested the exo in a total of 8 different job sites, which included civil, residential, including high-rise residential, industrial, commercial, and institutional, or ICI, and modular construction sites. And this all took place between October 2022 and August 2023. This is to say that the exo was tested year-round in the Southern Ontario climate in a variety of construction sites. In total, we had a sample of 41 participants. A third of them worked in residential job sites, and another third worked in modular. The rest were evenly split between ICI and civil. The majority of our participants were general carpenters, electricians, drywallers, and construction trades helpers. 80% of our participants were under the age of 35, and representative of the construction population, 93% of our sample were male. In our sample, 16 participants wore the exo for the entirety of the 2 days, and another 16 wore the exo for more than 1, but less than 2 days. And when we asked participants what were their reasons for taking it off, many reported that it was not applicable for the task at hand, things like flagging, driving machinery, or just going to the washroom. After they took off the exo, they didn't want to bother putting it back on, only for a short period of time, even if they were doing something that they found the exo to be helpful for. 9 of our participants wore the exo for only 1 day. We had 4 workers, so 2 drywallers and 2 skilled laborers, that initially wore the exo for a short period of time, just under 90 minutes, and they found it uncomfortable and decided to work without it. There were also 2 sheet metal workers who wore the exo for 1 whole day for the collection, but didn't wear it for a second day because they found the exo to restrict their mobility in accessing key tools from their tool belts, and this really hindered their performance. Oops. The 3 remaining workers were unavailable to participating in both days of the exo condition due to personal reasons. So that's a little bit about the sample that participated in our study. Let's start looking at the results, starting with the accelerometry data to get a sense of the worker's exposure to overhead work. What you see here is a 3-minute sample of a participant's processed accelerometry data. On the y-axis, you have joint angle, and on the x, you have time. So that's the 3 minutes of that sample. And the horizontal line here indicates 90 degrees of upper arm elevation. So anytime the red line goes above and below 90 degrees, we counted that as an overhead action. From that, we were able to calculate the proportion of time the worker spent overhead during their workday. On the y-axis, you have percentage of total work hours, and on the x, you have the exo and control conditions for days 1 and day 2. Looking at the chart, we can see that workers spent about 5 to 10% of their working day with their arms above 90 degrees. And that's quite significant because, as we mentioned earlier, workers who worked with arms above 90 degrees for even 5% of their days are 2 times more likely to develop shoulder injuries than those that don't. So this chart also shows that there wasn't any significant differences in overhead exposures between the 2 conditions. Given that overhead exposures between the 2 conditions were similar, did exos usage affect self-reported discomfort and fatigue? Well, from our data, we found small but significant increases in discomfort of the upper and mid back over the workday. And this was when workers were working as usual without the exoskeleton. So that's indicated by the blue line here. However, in the exo condition, discomfort appeared to remain steady over the course of the workday. So that's the pink line. And so this might mean that the exoskeletons may have helped reduce the onset of discomfort and fatigue over the course of the workday. Application of the exoskeleton amongst different trades across various job sites also allowed us to identify several tasks and conditions where workers found the exo to be helpful and unhelpful for. When we asked the participants which tasks the exos were good for, they told us that it was helpful for any task that involved overhead work. We had to probe a little bit further, and they told us that it was particularly helpful for lifting and positioning materials overhead and operating tools overhead. Some of these tasks included things like taping and mudding, especially the ceiling joints, installing upper tracks for framing, and overhead concrete drilling in bridge repair. There were also tasks that the exo was unhelpful for. According to the workers, the exo was not helpful or effective when working in tight spaces, like working in closets and framing around ducts. In addition, the exo wasn't helpful for tasks that were at or below shoulder height. So these included things like picking up small objects off the ground, downwards drilling, and measuring and cutting. General cleanup wasn't helpful for general cleanup either. We also asked participants whether they agreed or disagreed with 5 statements about the exo. So the bars here represents the proportion of responses for each of the agree or disagree categories. Blue represents agree, yellow represents disagree, and the gray is neutral. Most of our participants found the exo easy to use, and there were only 3 participants that disagreed with that. Over half of the participants agreed that the exo was comfortable, while less than 1/4 disagreed. Similarly, over half agreed or strongly agreed that they felt less physically fatigued and exhausted at the end of the day after wearing an exo. For over 70% of the participants, the exo did not hinder their work performance or productivity, with even over 1/3 saying that exo improved their performance and productivity. We also asked participants which method, with the exo or without the exo, they preferred for overhead work across 11 variables. And it was pretty even split between performance, control, accuracy, performance, and speed. But there were a couple variables where over 2/3 of participants preferred one method over the other. So the blue represents preference for the exo, and the yellow represents preference without the exo. So we found that 82% preferred to wear the exo to reduce the required effort when performing overhead tasks. And this was really one of the expected benefits of wearing the exo. So we know that it's doing its job. On the other hand, 3/4 of our participants preferred their usual method based on maneuverability. Many participants did find that the exo to be a little bit restrictive in some of their movements, which is also something that's observed in the literature. Given all this, 2/3 of our participants said that they were likely or very likely to use the exo if it were provided by their workplace. However, they did caveat it by they did caveat their response saying that they would put on the exo when they needed to do overhead work in an open space for an extended period of time. They said that exos weren't something that they would be using on a daily basis due to the non-cyclical nature of their work. For the designers and manufacturers in the crowd today, we also asked participants to share their ideas and recommendations as to what they would like to see in future exoskeletons. And this is what they said. The exo should be compatible with other tools and PPE. So participants felt encumbered when wearing the exo over tool belts and sometimes over harnesses and jackets as well. They said that the exo should be compatible with tool belts and harnesses to minimize the amount of straps and belts around their waist and shoulder areas. Some participants chose to take off their tool belts to wear the exo, and this decreased their productivity because their tools were not always readily accessible. This brings me to the next recommendation. Workers should be able to access tools on their tool belt. Almost 3/4 of our participants mentioned that the exo reduced their maneuverability. The movement that was restricted was reaching to the back of their thigh, reaching for the back of their thigh. And that was an essential movement for accessing tools on their tool belts. They also wanted the ability to adjust the level of arm support without taking off the exo. And as I mentioned earlier, some participants found the exo to interfere with non-overhead work. And so they wanted to be able to adjust the level of arm support or turn it off completely without needing to take it off. 4, it should also be compact and close-fitting to allow for working in small spaces. 5, the material should be breathable for extended use. So a few of our participants actually reported skin irritations where the arm cuffs were, even though we laundered the padding each night. This was particularly evident amongst those working in warmer environments, such as outdoors during the summertime or in heated work sites. Lastly, participants wanted some type of mechanisms to prevent debris from entering the arm cuffs. Since workers were cutting or drilling overhead, debris was falling into their arm cuffs, and workers had to repeatedly take off the cuffs, shake out the debris, and put it back on. So summarizing today's webinar, we talked about what exoskeletons are and the barriers and facilitators to its adoption and construction. And we also talked about our study that tested exoskeletons on a variety of construction sites and several different subtrades. With this study, we hope that it will help decision makers and manufacturers better understand the use cases of exoskeletons and support in making exoskeletons even more suitable for its use in construction. Ultimately, we hope that it will contribute in building and maintaining our construction workforce. If you'd like to know more about the study, the research is now published for open access in Applied Sciences, and I'd be happy to answer any questions that you may have right now. Thank you.
Thanks so much again, Bronson, for that wonderful presentation. Yep, just as a reminder to the audience, in the post-webinar email, I will be sharing information on how you can connect with us at CISWP or with Bronson himself. And if anything, if there's a link to the paper, Bronson, I'll probably share that as well.
Perfect.
Looking at the Q&A, it seems like there are a couple questions that have been submitted. So thank you to the audience members who have participated. It's awesome. All right, we'll start with question 1. Is there a cost benefit or return on investment estimation similar to that of the Washington State Ergonomics Cost Benefit Calculator? So in other words, is it possible for people to see if people put in an investment of X dollars, it will be paid back in 2 years of use or something like that?
Yeah, so that's a great question because that's one of the main drivers for adoption. And we recently, a couple years back, we did perform a scoping review, systematic review, sorry, to look at if there were any research available out there looking at exoskeletons' impact on work productivity, work performance, work quality, as well as any economic analysis as well. Mm-hmm. And we unfortunately didn't find any tools out there at the moment.
So not yet.
Not yet.
Not yet. All right. So maybe stay tuned for that. All right. Question 2: were participants trained in your study in any ergonomic principles prior to participating in this study? And do you think that including these, the benefits of using an exoskeleton, will the users be more trained on gaining more out of using the exoskeleton?
Gaining more. Yeah. So
first question is
were they trained on ergonomic principles
before the study?
Before the study. So for our own study, we had a day 0, which was a study orientation to tell participants about the study, what they're getting into, as well as doing their demographics. On this day also, though, we did do an orientation for exo fitting. So we got the exo fitted for their sizing. In that sense, we trained them on fitting, but to our knowledge, we didn't ourselves give any ergonomic training on ergonomic hazards. A lot of the work sites that we went on had daily toolbox talks. So there were some safety talks at the beginning beforehand. So not us, but it was the workplace that did that training. I think there was a second part for the question as well.
I'll read verbatim just so I don't mess anything up. Would this be included in the benefits of using an exoskeleton with users being more trained on positioning to gain the most out of the exoskeleton? So in my mind, I think the question is like, I won't want to brush my teeth, but if you tell me the actual benefits of it, I might be more inclined to.
Yeah. So absolutely, I think being trained appropriately on how to use the exos would definitely help users use them appropriately rather than using it as a toy. It's really a tool in their toolbox to reduce the risk of MSDs and reduce the level of effort needed for overhead work. So there are times that the exo might not be helpful for, and so when they're using the exo for everything, even times when it's not helpful for, that might cause more fatigue, more muscle activity than needed. Adjusting the tension appropriately is going to be a huge factor too, because when we were testing, there was a lot of workers that wanted more attention. They wanted to see
support,
how much
helped.
the exo could help and how much of their work can be reduced. But I think that's a key factor in knowing that we're not over relying on the exoskeleton.
100%. So it sounds like training on the how of how to use it will help with adoption. And then in terms of training on the why, you said that that the workplaces were doing toolbox talks and speaking about the risk of and hazard of overhead work. Next question, another question that we have is, you made interesting points about the psychosocial barriers to exoskeleton adoption. How can employers improve or potentially improve the way workers perceive exoskeletons in the workplace?
Yeah, that's a good question with the psychosocial aspects. How can the question is, how can employers improve?
Yeah, how can we change the way that workers perceive them?
Yeah, so I think first that has a lot to do with the ergonomics training to understand that this is a tool that will reduce the risk associated with overhead work. This is speaking towards, I believe, that perceived sign of weakness for those who wear the exoskeleton in the culture. That we had a couple participants when we were recruiting, that people didn't want the exo because they felt, oh, I got my own exo here, right?
Yeah.
But what we also saw in our data was that many of our participants did like the looks of the exo, so they felt cool in it, and that was a big factor of having a tool that they felt cool in, rather than feeling like they needed help. So in terms of how participants felt about it, that wasn't the same finding as what the construction stakeholders were mentioning.
Yeah.
Exactly. Yeah.
So just to add on to that, quick yes, no. Did any of the workers ask to keep the exoskeleton for more than the planned 2 days?
Yeah, so after the full study, we were on site sometimes for over a month at certain construction sites, right?
Yeah.
We weren't able to do everyone all at once. We had to break it down. So we had the participants wear the exo for 2 days, and then without the exo for 2 days. And after that study period, some participants would ask, "Hey, can I keep using it?" And we would drop off an exo for them in the morning and let them continue use it. So there was that desire to continue wearing it, rather than, oh, we're done the study.
Yeah, I'm done.
I'm never wearing it again.
Yeah, I don't need to wear that anymore.
So,
that's fantastic. That's awesome. All right. Next question. So with exoskeletons making harder work potentially more manageable, is there a risk that workers may overexert themselves more than they would have otherwise? And employers, they may potentially abuse this using exoskeletons?
yeah, that's a great question. And we have had some employers want to participate in the study because they wanted to change a 2-person job into a 1-person job. So that's very real. And so also there could be a false sense of security using the exos. So in our data, feeling safe, many people prefer the exos because they felt safer working with it as well.
Yeah.
But how safe? To what extent? That's one of the questions we're actually trying to answer right now, to provide better guidelines to employers. So we're conducting a lab study, kind of recreating the Schnook table to see how, while wearing the exo, how much more weight can you lift without getting fatigued with the exo on, right?
Yeah.
And so we're recreating that, and we're also taking the biophysical measures as well, biophysio measures, to make sure that we have an objective measure that they're not getting fatigued and their perception is matching with fatigue or not?
Cool. So that's definitely something that's getting studied right now.
That's a great
Wonderful.
question.
I think we have time for maybe one more question before we call it. Does the variability in a worker's role and environment impact the appropriateness of recommending exoskeletons?
Yeah, absolutely. So like with construction, things are always changing. Sometimes you need to go grab materials. You're going room to room. You're changing tasks constantly, and it might not be appropriate when you're not doing overhead work for a prolonged period of time.
Yeah.
We had some participants suggest that we use exoskeletons kind of like a safety harness. So when they know they're going to be doing working from heights, they're going to put on the safety harness. When workers know that they're going to be performing overhead tasks for a prolonged period of time in open spaces, I think that's when it's appropriate to be putting on exos.
Yeah.
Other than that, might be a lot taking on and off. Yeah.
Which makes sense, right? You're not going to use a hammer for every single job and all day. So it's a tool at the end of the day.
Tool.
Here's another quick one, so that we can finish on a nice quick note. Do you plan on testing other trades and other exoskeletons?
Yeah, so currently in our lab, we have a couple other exoskeletons. One that was a full body design for brick and mason. And we also have a hand exoskeleton that we're planning to test out. So that's coming down the line as well. And
very cool.
All
right.
Yeah.
Thank you so much, Bronson. With that being said, thank you so much again for joining us, and to you at home, thank you so much for joining us. Huge shout out and thank you to the media production team here at Conestoga College. I hope everyone has a wonderful day. If anyone has any further questions, keep a lookout for the post-webinar email, and you can reach out to us via email there. Thanks, everyone. Have a lovely day.